Hello Internet, my name is Quinn and this is Blondihacks. I'm finishing up the Acute tool and cutter grinder system this week. We're going to give this thing a test drive for the first time. This is going to be a little bit of tutorial for how to use this thing, but mostly it's going to be me trying to figure out how to use this thing. I will link below to the official Eccentric Engineering videos on how to use this thing if you want just a straight up tutorial, but I'll show you what it's like to use this thing for the first time and get the feel of it. So let's go. Here is the Eccentric Engineering Acute tool sharpening system. Whether you bought it or built it like me, you will end up with something that looks very much like this. Let's go through all of the major components. We've got the work arm with the work head on it here. It's a pair of 4-bar linkages. Very cool. Then up here is the fence or track that the work head runs on. This is the tool block that holds the tool that you're sharpening. Then there's a top slide, which is used for certain types of tool grinding on the work head. And then this is the setting block. Now over here, we've got the collets, if you will. They're tool holders. They're not really collets, but they come in square versions for lathe tools and similar square tooling. Then they also come in blank, so you can drill or bore or ream or broach them to suit. And I've done that with one here. I've reamed and bored this one for my 3/8 end mills, which is the most common size that I have. They also come in hexagonal profiles, which you'll see is important here in a moment. So these blocks go into the tool block. And the key feature of them is the shape is what allows you to index the tool that you are grinding. So the square one allows you to grind 2 and 4 flute end mills because you can index that collar around for each flute. So the hexagonal ones would be for 3 or 6 flute cutters. And then the round ones are also used with these little angle templates that I'll show you in a minute. Those are also for setting your grinding wheel. And then there's also these series of templates here, which are for setting all the different angles on the work head for grinding the tool. I'll go through how all of this works, and you'll see how clever a lot of it really is. It's a pretty neat system. Before you can use the system, however, it has to be adapted to your bench grinder. Every bench grinder is different, so the table comes blank, if you will, and you modify it to fit your particular bench grinder. So you can center it or you can put it offset depending on what works best in your situation. Regardless, the first step is to remove the current tool rest, which is a shop-made one that I designed and built several years ago. I do have a 4-part video series on this guy if you're interested, and I do have drawings and plans for it as well. It's a little bit over-engineered, as most things I build, but it has served me quite well for many, many years. A little worse for wear, but it's been a trooper. Now, to get this table set up, first of all, I'm going to need room in front of the grinder for it. I briefly considered mounting it to the front of the table, but there's not nearly enough reach on the table legs of the tool rest for that. So it's going to have to go in front of the grinder wheel, or in front of the base of the grinder, which means I'm going to have to push the grinder back a bit. That's not a big deal. I just need to know kind of how far back, how much room I'm going to need in front of it. I took a couple of measurements, and I figure if I push my grinder base back by the same amount as the width of the base on the tool rest, then I should have enough space for everything. The nice thing about a steel bench is that this kind of modification is very, very easy. It's no big deal to move tools around, drill new holes, bolt things down in new places, etc. That grinder has not moved in quite a while, actually ever since I first moved into this shop and bolted it down. This is the first time it's moved. I'll mock things up real quick before we start drilling holes to make sure that this general approach is going to work. It's looking pretty good. Yeah, I can see that once I cut the notch in that table for the wheel, that is going to land in a good place. Now the depth of the table around the wheel is still TBD, but for now let's get the bench grinder mounted in the right place because it's clear that this general arrangement is going to work. The table has a ton of adjustment on it, so if you could just get the bench grinder in the ballpark, then it'll be fine. So I will transfer punch new holes for this position on the bench grinder. I always like to circle my punch marks on a project like this because it's very easy to lose them, especially on a big, flat, dark-colored surface like my workbench. I do love having steel workbenches, though. It's really, really nice. Now I got out the big drill, and let's drill these holes out, starting with a pilot drill on those punch marks. Modern cordless tools are fantastic. They've come so far since I was growing up when they were arguably useless. They're amazing nowadays, but there is still a place for corded tools, and one of those is drilling steel with a hand drill. You can still get way more torque and better low RPM performance from a corded tool than you can from cordless. And when drilling steel, the two things you need are low RPM and pressure. And that is something that corded tools can still do a lot better. They can handle running at low speed for long periods of time. Here's a trick my dad taught me. Attach the chuck key to the cord at the plug end. And that does two things. One, you never lose your chuck key, and two, it forces you to unplug the tool to change the cutter in it. Free safety. I've ranted about this lots before, and well, it's my channel, so I'm going to rant again. The number one thing that DIYers and newbies to metalworking do wrong when drilling steel is they run the drill too fast and they don't use enough pressure. Drill presses work incredibly well when drilling steel, and the reason is because they put a lot of pressure on that drill, hence press, drill press, and they can run the bit slowly, so your surface speed is correct on those cutting flutes. So when you're drilling steel with a hand drill, you must become the drill press. Go slow and go heavy. You should see proper chips coming off of that drill just like you do on the drill press or the milling machine. If you see powder, that means the drill's running too fast and you're not using enough pressure and you're drilling like a DIYer on TikTok. Alright, now that I've alienated a good 2/3 of my audience, let's get this thing mocked up and see if it's going to work. I use relatively undersized bolts to mount this grinder because, you don't need 5/8 grade 8 hardware to mount a bench grinder. And using smaller bolts gives me lots of adjustability on the exact position of this, which I think is going to come in handy for mounting this table in front of it. The next job then is to figure out how deep of a slot I'm going to cut in the table, and I do want to have it centered, which means that the body of the bench grinder is going to be a problem. I don't have a lot of clearance on the left of the wheel, and this table is very, very wide. I do still want it centered, though. I find it really nice to have the same amount of working area on both sides of the grinding wheel. I also don't want the table right up against the body of the bench grinder because you need room to move the table forward as the wheel wears. So I want to allow some space for that. I kind of landed on a compromise. My previous tool rest that I had built had a 25mm depth on it. So for this, I'm going to go 20mm because 25 was lots on the old tool rest. I never needed that much. And 20 will give me a lot more adjustability for wheel wear with this wider table. And then if I need to, I can clearance the table later around the body of the bench grinder, but I'd like to avoid that if I can. A 20mm depth of groove seems like it's going to achieve all of those goals in pretty reasonable fashion. I can always deepen it later if I need to, so let's start conservative and see how it goes. I'll scribe that out on the center of the table. As I said, I looked at the various options for asymmetrical layouts, but I know from experience with my previous tool rest that it is frequently nice to have space on both sides of the wheel, just for lining up tools to get the right angle on top rakes for lathe tools and so on. Having a little bit of space all the way around is really nice. I'm going to rough cut out that groove on the bandsaw. It's a pretty big chunk to remove, so the bandsaw will make short work of that. And I'll take it over to the mill and clean up those saw cuts and bring this slot to final width. The actual width of this slot will depend on how big your grinding wheel is, of course. I know from making a previous tool rest that somewhere between 50 to 80 thousandths of clearance is about right. So this is a 1-inch grinding wheel that I'm using nominally, but it actually measures about 980 thousandths. And then I made this slot about 30 or 40, maybe 50 thousandths over 1 inch in width. That seems to work well. You do want it as close to the wheel as you can get it, especially if you're making small parts like I am. The less of a gap you have between the table and the wheel, the safer that setup is, because the less likely it is to get parts trapped down between the wheel and the table, which can jam up the wheel and cause it to fracture, which is an extremely dangerous situation. This is why you never take the sheet metal guards off of your grinders. A lot of newbies to metalworking assume those guards are there to keep you from accidentally touching the wheel while it's spinning, which is also a nice benefit, but really what they're there for is to catch the shards of that grinding wheel if it ever explodes. And grinding wheels do have a slight tendency to explode if they become fractured or cracked in any way. They are like a little grenade 6 inches in front of you when they're spinning. There's an enormous amount of kinetic energy in it. Let's do a little test fit now, see if I got the width right. Finish in there is really nice, unnecessarily so of course, because no one's ever going to see it, but that looks like that's going to work really well. I've got enough clearance that the wheel is not touching it, although grinding wheels are self-clearancing, which is kind of handy, but still, I don't want the wheel to be touching. Now I just need to square up those corners and we should be done. The end mill leaves a corner radius, of course, that's going to interfere with getting a nice close fit on the grinding wheel, so I'll clean up those corners, make them sharp on the die filer. I do love this machine. I've gotten a lot of use out of it since building it. One of the more useful little power tool projects that I've done on the channel, I'd say. Next up, to get the table mounted, I'm going to do it a little bit differently. I'm just going to drill and tap the steel table directly. Again, another nice feature of having steel benches is you can tap threads directly into it and mount things very easily that way. This bench, if you're wondering, is actually a Canadian Tire workbench that has a really crappy particle board top on it, but really nice steel legs. So I bought it for the legs, essentially, and then I went to my local steel yard, bought a great big steel plate, and countersunk bolted it to the top of the legs, and got a very inexpensive and very skookum steel workbench. So that looks like it's going to work. That mounting is working just fine. It's a little bit short. I'm a little bit below the center line of the wheel if the table is level, which I don't like. You got to be above the center line of the wheel for safety reasons. However, I did get a really nice gap there, so I'm happy about that. We'll come back to that height situation, but for now, let's take a look at grinding an end mill, because I would actually like to try doing that now. So this is an end mill that needs grinding. I don't know if you can tell on camera, but this corner over here is dinged over, and that's actually because I dropped it. So this does not cut very well at all. I'll do a little test cut here so you can see what I mean. Real quick before that test, you really need to understand end mill geometry in order to regrind them, of course. There's essentially 3 angles that make up the end of an end mill. You've got your primaries, that's an angle that creates the cutting edge. Then you've got your secondaries, that's a clearance behind the cutting edge to prevent rubbing. And then you've got your gashing angle, which is kind of like a secondary clearance. And all of these are at a slight helix twist to follow the angle of the side flutes as they travel around. So it's complex at first glance, but really there's not that much to it. For sharpening or regrinding an end mill, all you really need to do is regrind the secondaries and then put new primaries on top of that. Finally, the end flutes have an angle on them when viewed from the side. There's actually a V shape. There's a clearance that goes towards the center of each flute, and that's so that the insides of the flutes aren't rubbing, as the outsides of the flutes, which are doing most of the work in any end milling operation, are doing the cutting. The insides of these end flutes really only do work when you're plunging with that end mill. Now, while this test cut is running, let's talk a little bit about grinding end mills. This is something that I think a lot of beginners, especially to the hobby machining world, are very excited to do or expect that they're going to need to do, because in most hobbies, resharpening or regrinding your cutting tools is something you need to do pretty regularly. So it feels weird to have a machine shop and not have a way to sharpen or regrind everything in that shop. But honestly, the truth is, regrinding end mills is really not something you generally need to do. I mean, I've been hobby machining for 10 years, and in all of that time, I've only ever acquired 3 end mills that are currently in need of a regrind, and all 3 of them are because I dropped it. So if you just use end mills normally and take good care of them, they really, for a hobby shop where you're not running them all day in 3 8-hour shifts, cutting hard on tough materials, end mills just really last a long time. And it's usually not worth the trouble to regrind them, quite frankly. Especially if you buy good quality ones. Don't buy cheap end mills, buy good quality ones like Niagara Cutter or some of the other big quality brands. Furthermore, when we're talking about regrinding end mills, we're really only talking about regrinding the end flutes. And that does 2 things for you. First of all, because end milling is mostly what you do with an end mill, like I'm doing here in this example. So the end flutes are what get dull. And also the lower parts of the side flutes get dull, both from side milling at the bottom of the cutter and also from deep cuts when you are end milling. The corners effectively wear out. So if you regrind the bottom of the end mill, you effectively shorten the side flutes at the same time and remove the worn area of the side flute. You don't generally regrind the side flutes on an end mill, both because that then changes the dimension of the end mill, which makes it of much more limited use, and also the side flutes don't tend to wear out because side milling is less common than end milling, and you tend to use different areas of the side flutes every time, so they last a really long time. Now, I know you can't really tell on camera, but that surface finish is terrible. It's very, very rough because that end mill is only cutting really on one tooth. The whole surface is rough and scratchy to the touch, just generally terrible. So this end mill definitely needs regrinding. Now, let's get the work arm in here and give this a try. So the first step in this tool system is to set the angle of the table. You got to start by putting in all of the accoutrement that you're going to use for grinding, and then you use this angle measuring gauge that the kit includes that has this curved scallop cutout in it for 8 degrees, and there's also a 5-degree one. And this allows you to set the angle of the table relative to your grinding wheel, regardless of the diameter of the grinding wheel, because it's using 2 points of contact on that template. So by setting the template on the top surface of where the tool is going to be ground, that's why you have to have the workhead and everything in place, because the angle depends on the height on the wheel as well. You can use that template to set the angle. Now, at this point, I realized my table is too low. I really can't get comfortably above the center line of the grinding wheel, so I found some scraps of 2-inch square tubing in my bin and knocked out some quick riser blocks for the table. And this will give me the range of adjustments so that I can get above and below the center line of the wheel as much as I need to. I guess the system is designed for a little bit smaller grinder than I have. Now, as I was saying, I set the angle of the tool head relative to the grinding wheel like so. And it's funny, the table actually ends up tilted slightly downwards, but you can see where the tool is going to be when we grind it. There will be a back rake effectively of 8 degrees relative to the wheel. So that's what we want. In comes the fence now, and I immediately realized a problem with the fence that I didn't notice while I was building it. The left-hand kip handle is supposed to be for adjusting angle, and the right is for adjusting position. You're supposed to be able to set them independently. To make that work, I had to add a shim under this side so that when the angle adjustment clamps, it does not clamp on the table. It's only clamping the angle of this sliding block. That was an error that I made reading the drawings while I was making this because I misunderstood how the mechanism works. So now I can change the angle of the fence, lock that down, but still slide the fence wherever I want, and then separately lock the position of the fence. And that's crucial for how this fence works. As you'll see, you have to be able to lock the angle separately from position. So that's all working correctly now. Let's get the workhead in here. The workhead has this alignment pin that holds the workhead at 90 degrees relative to the fence. And that allows you to set the angle of the fence by putting these templates that the kit includes in the workhead. So I can set the angle of the fence relative to the grinding wheel. Now these templates are really clever. Because we're setting the angle relative to the surface of the wheel, it means it does not matter if your table is square to the bench or square to the grinder, and it also does not matter if your wheel is dressed square, which it probably isn't, because we're always setting the angle relative to the wheel itself. Very, very good idea. Good design on that part. The fence is then set at 2 degrees. Now I'm going to come in and set the workhead to 5 degrees the other way, giving us a 3-degree angle on the head. The purpose of the 2-degree angle on the fence is that it turns the grinding wheel effectively into a single point cutter, like a surface grinder or a lathe tool. It makes sure that we get straight cuts that are dictated only by the motion of the head and not by any imperfections in the grinding wheel itself, such as crooked dressing and so on. Now this 5-degree angle, or effectively a net 3-degree angle that we're putting into the workhead, creates the relief on the end of the end mill, the clearance angle on the ends of the flutes. Time for the tool block now. I'm going to put the tool holder in there, the square one that I bored out previously. I'll put the end mill that I want to grind in there and tighten that down using the surface of the table to index it 90 degrees. Now in comes the tool setting block. It's got a bunch of features on it that I'm not entirely sure what they're for, but the one feature that I do know from the official videos on how to use this thing is that these surfaces are for setting the tooth on an end mill that you're going to mill. This gets the flutes horizontal relative to the tool block. Now the tool block has a 5-degree angled surface on it and a flat surface on it. The angled surface is for creating the secondaries on the end mill, so we're going to start with that. And this 5 degrees plus the 8 degrees on the table gives us a total of 13 degrees of secondary angle. Now I bring the fence in nice and close to the wheel, which I can do without affecting the angle, remember, because of how those 2 kip handles on the ends work. And I need to get the end stop now set on the fence, because I want the end stop to stop the cutter right when it's centered on the edge of the grinding wheel. Then I can use the fine feed on the top slide to set my depth of grind and give me just enough travel to start grinding on the end of that end mill. Then I started doing the grinding, and I'll explain the technique here in a second, but I immediately noticed I had made a mistake in my setup because my secondaries were going the wrong way. I had reversed the 5-degree angle when I set the workhead, so I had to flip it 5 degrees the other way, and now here's the basic grinding motion. You go in against the wheel till it starts grinding, and then you pull across the cutting edge, and then pull back on the workhead, and then slide back to center against the stop, and repeat. You're going in a little clockwise circle with the workhead and all the little slides. You just keep doing that until the depth on your secondary looks good. You can adjust the fence stop for getting the grinder to stop in the center of the end mill as needed. Then once you're ready to do the other flute, you flip it around 180 degrees, indexing with the tool holding collar like so, then put it back on the workhead. And because all the stops are set, we can now automatically grind the other flute, rather the other secondary, to the exact same depth and angle. On pretty much my first attempt, I was able to get decent looking secondaries. That's looking good. Nice and even, nice and centered, nice and symmetrical. Now we flip the block over to the flat side, and this will grind the primaries. So we're subtracting 5 degrees now from the angle, but we do the exact same grinding motion, this time grinding a lot less because we want to aim for a primary angle about 1 millimeter wide. Unfortunately, this is where I really struggled with the system. I could not get decent looking primaries. That's a hot mess. That's never going to cut anything. And in fact, I've got a high spot in the middle, so there's something wrong with how my angles are being set here. I'm not exactly sure what I've done wrong. In principle, I've done everything as shown in the official Eccentric Engineering tutorial video on this system, but clearly there's some user error here. I don't know what I'm doing wrong. I made a half dozen attempts at this, and this is actually the best one that I got, if you can believe it. This is not a good looking set of primaries, but the clearance on the end looks okay, and well, it seems like it will actually probably cut, so just for giggles, let's give it a whirl. Into the mill it goes on that same test piece that we did at the top of the show, and let's see what happens. Now, even if this doesn't cut, I'm not too broken up about it. As I said, regrinding end mills is not something I really need to do very often, and it's not something I'm looking for out of this kit, and you should think twice if it's something you really need as well. And the other important takeaway here is that there is absolutely a learning curve to this Eccentric Engineering system. It's very sophisticated and can do many things, but it may not be quite as easy as the Eccentric Engineering tutorial videos make it look. At least that's my experience. There's definitely a learning curve with this system. The results are actually interesting. There's a number of long, straight artifacts in it where there's like a ridge, and I'm pretty sure that's where there's high spots in my grind. My clearances aren't all correct, so there's parts of the cutter that are rubbing. But in between those artifacts, actually the surface finish is outstanding. So we did make a cutter. It is cutting, and it's actually better than it was, but it's not really an acceptable grind as is. So we're closing in on successful grinding of an end mill with this system, but more practice clearly needed. Let's move on then to a lathe tool, which is something I'm much more interested in for this system. I've got a standard 3/8 lathe tool that I ground by hand. The grind on it is okay, but not great, so let's fix it up. I'm going to use one of the square tool holders in the tool block, and we'll get that tightened down. Now, to get this thing aligned, these templates have one more trick up their sleeve. They have a 0 degree mark on the inside that lands in these grooves on the round tool holders. So you place it inside the template like so, and then place it down against the table, allowing you to index these round-headed tool holders. Pretty clever. Now I've got the tool held square to the tool block so we can start grinding some surfaces. I'm once again going to reset the table angle because we're not using the top slide for this setup, so I have to set the angle again because remember the height changes the angle against the grinding wheel. I'm also going to remove the fence because we don't need that, and I'm going to set the angle to the wheel to 8 degrees, which is kind of a good general purpose clearance angle for pretty much all lathe cutting tools, and I'm going to start by grinding the end clearance on this tool. So the workhead is holding the tool at an 8 degree angle relative to the face of that wheel. And it's a simple matter of using the workhead to pan across. So this is just like grinding a tool bit by hand, except that the workhead is ensuring that the angle stays consistent between each pass. So that is a very, very nice way to grind a lathe tool accurately. I can also cheat a little bit and use the side of one of these templates now to set the workhead at 90 degrees to grind side clearances on this tool. Or if you wanted to do 88 or 92 degrees or something like that for a grooving tool to get fall-away clearances down the sides, you could absolutely do that. I don't actually need side clearances on this tool, so instead I'm going to do the top rake. So I'm going to index the tool around 90 degrees, once again using the inside of the angle template in this very clever setup. And then I've got the tool effectively sitting sideways at 90 degrees, and I can then grind a top rake. I've actually angled the workhead a little bit more than 90 to give myself a few degrees of top rake on that tool. And a couple of touches like that on the side of the workhead. Again, using that space that we've got around the grinding wheel, and that'll give me a nice simple top rake for this tool. And that's creating a compound angle, mind you, that's falling down and away from the cutting point. And then I'll just freehand a quick nose radius on there. All right, well, it's a much better looking grind than I had done previously by hand. Let's see how it cuts. And survey says it cuts excellent. I mean, I knew it would just by looking at it. Lathe tools are really not very complicated once you've done a few of them, and it's pretty easy to tell by looking at them if they're going to cut. And that does indeed cut beautifully. That's a very, very nice finish on that. You're not going to do much better than that. Final thoughts on this system then? Well, the table is actually one of the standout features of it. It's honestly worth buying the drawings just to build this table, because this is without a doubt the nicest tool rest I've seen for a bench grinder. So just building the table is a worthwhile effort. The only criticism I have of the table is that the bolts do tend to loosen while you're working the kip handles, these cap screws. So I would probably replace that with a hex-headed bolt and weld a little stopper tab on there to keep the hex from rotating so that it stays in place when you're operating the kip handles, but you can still take everything apart. Overall, I think it's an outstanding system for grinding lathe tools. I'm very excited to use it for that, especially for doing really accurate tools like Acme threading tools, regular threading tools, chamfering tools, angled form tools, that kind of thing. This system is going to be really terrific for that. That will definitely be the main thing I use it for, in addition to it just being a super deluxe tool rest for general purpose use on my bench grinder. As for grinding end mills, I may take another swing at that. I was getting a little better at it, but I think I'm a long way from getting results as good as the tutorial videos from Eccentric Engineering show is possible with the system. But again, probably not worth a ton of effort given how rarely, in fact never, I've ever honestly desired to regrind an end mill. So your mileage may vary on that. I'm not going to recommend or not recommend the system for that because I really haven't had enough experience with it to be fair to you or to the system to give it a thumbs up or thumbs down for grinding end mills. It's clearly possible to get excellent results with it as shown in his videos. So just be aware there is a learning curve with it, and it is very sensitive to having built everything correctly. If you're going to build this thing yourself, make sure you nail all those tolerances. All the components have to move smoothly together. There's a lot of moving parts on this system, and everything has to move together smoothly. Overall, it's one of the simpler home tool and cutter grinder systems that I've seen for bench grinders. There are a lot of systems like this out there. Harold Hall's book, for example, on building one. They're all very complicated because tool geometry is complicated, especially grinding an end mill. There are a lot of very tricky features in an end mill that all have to be just right for them to cut properly, and there isn't a very simple system that can grind that. It has to be somewhat complex. But this is probably the simplest system I've seen that is capable of doing it well. So it gets points for that. That is where I'm going to leave this, though. I hope you've enjoyed watching me build this tool sharpening system in this series, and hopefully you got a sense of how it is to use it in this final video. I really enjoyed building the system. It's a lot of fun as a project, and the final result is definitely useful as well, especially if you just really need to level up your bench grinder tooling in general. I think it's a great tool system for that, regardless of whether you use some of the features or all of the features. Thank you for watching. Thanks to my patrons for making all of this content possible, and I will see you next time.